Yes, dear students, last class we have discussed about the map reduce and map reduce, reduce task, and also the map execution model, which is a programming model. And today we are discussing about the map reduce execution steps. Here we can see this diagrammatic representation where it consists of map reduce execution steps. Accordingly, from HDFS, we will be having a input data, and this input data will be divided in terms of a smaller units, where that smaller unit of a data is available in a split task or a split unit, and this smaller unit will be having a data in terms of a text format that will be converting by using RR. RR stands for read record or else record reader we can say. And this record reader will be converting the text format input data into the key value pair because map task always works on the basis of key value pair. Henceforth, the data, whatever we had in a split format or a split unit, it is available in the text format that will be converting by using a function called it as a record reader. And this record reader will provide the data, that is the input data in terms of a key value pair in the map task. As soon as the map task receives the input from the record reader, then we will be having the next function called it as a combine. And here you can see the directed graph or the directions from input split RR and also the map. So the first step is for the record reader. Next, it receives the input as a key value pair. Later, that input of the key value pair will be providing to the next functionality, calling it as a combining. So this combine unit will be working in the map reduce, and this is a semi reducers in the map reduce, and this function is a optional class, and this map reduce driver class specify the combiner, and later the combiner executes on each machine that performs a map task. This map task and the map task is going to have the values, each and every values which is available in the combiner class. Combiner function which is already there in the map reduce function, and it is going to optimize the map reduce tasks, and that task will be aggregating the information locally before the shuffle and sort process starts. Before the shuffle and the sort process starts, it is going to aggregate all the output of all the map tasks together in the combiner class. Once it provides the information to the shuffle and the sort function, then it is going to receive the information in terms of a key value pair, and it will be collecting together in terms of a group. Then it is going to create each and every group of the keys, and shuffle output will be available in the form of key comma then the list of values. For example, if I have a k1 v1 for the first key value pair and k2 and the v2 for the second key value pair, the different subsets are going to be created for the intermediate step. That intermediate step will be shuffled over in the shuffle process, and here we can see from the outer nodes and also the inner nodes, other nodes will be connected to this particular shuffling process. As soon as it receives the output from the combiner class, or the combiner function, it is going to shuffle the data. That shuffling will be in terms of the key value pair, that is a k value comma list of the values, where it consists of a different subsets of the intermediate keys, and along with the keys it will be available as a key space, where it assigns to each and every reduce node, each and every reduce node. Then those intermediate nodes, we are calling it as a partitions. So that partition will provide us a semi mappers in the map whole map reduce execution steps. As soon as the partition processes the output of the mapper class, then of course it has to submit the output to the reducer class. So before coming to the reducer class, the partition will be having a local partitioning before the phase is going to start of the reducer. Later, the output will be coming to the output files, and this output will also be available in the key value pair, and that is going to be stored to the Hadoop distributed file system. But there is a one more information, that reduce task. So this reduce task will be assigned with the Java application programming interfaces, and that includes the reducer class. Even we have a API for the reducer class, where it can pass the information by using a public class, and also it can throw an exception based on the data size. For example, if we will be having K1 V1 is a one set, K2 V2 is a another set, K3 V3 is a another key value pair. Like that, we will be having Kn comma Vn of the values. So it will be creating subsets from the shuffling process. Then that output will be coming on to the reduce phase. Then the reduce phase will be using the Java interfaces. Then that output is going to be extracted and analyzed. Then that analysis of the data is going to be stored in the output files. Later, it is going to store to the HDFS storage or the Hadoop distributed file system. And next, we will be having matrix vector multiplication by MapReduce. Here, we will be having the number of applications where it needs multiplication of a n cross n matrix. For example, if I have a matrix A which will be consisting of the values, that value is available from our each and every data set, and according to the matrix A, it will be with a b vector b of a dimensionality n, and this dimensionality of a n will be having each and every element of the product. That element is available in the C vector or a C resultant matrix, that will be having a relation with the dimensionality of a n with the matrix A as well as the vector B. So that here we can see Ci is equal to the summation of j is equal to 1 to n, where Aij then Bj, where this is having an example of a given calculation which is under here. So let us assume one of the matrix A which is equal to 1, 2, 4, 5, 1, 2, 4, 3, 1, and the vector B will be the representation 4, 1, 3, and it will be follows up as per the normal matrix multiplication to where it uses the map reduce, and this matrix multiplication, that is the resultant C is equal to A cross B, which is equal to 1 cross 4 row as well as a column, row as well as a column. We will be having the output, that is a C resultant matrix. This suggests us the values. So this is a value I have for a particular key that shows our matrix multiplication. And next we have a relational algebraic operations. These relational algebraic operations consisting of same as of a DBMS concept. There we need to have a selection for a data, and we have a projection of a data, union of a data, intersection and the difference of a relational schema, difference of the relational schemas, symmetric difference, natural join, and also grouping and aggregating by the map radius. So here with I'll be concluding the topic, and next class I'm going to discuss about the relational algebraic operations in depth. Thank you dear students.